All right.
Okay.
So if I come over there to you, Stella, what did P stand for?
P standard for pressure.
That's exactly
That's
right.
exactly right.
All right. And
All
while I've
right.
got you
And
there,
I've got
Stella,
you
if
there,
you don't
Stella,
mind
if you
telling
don't
me what
mind
V
telling
stands for.
volume.
What was in?
Number of moles.
Yeah, literally the
Yeah,
number
literally
of
the number of
particles of gas. And what was T?
temperature.
Perfect. All right. Um, Thank you, Stella. Swasti, there was one thing that was tricky about temperature. What did we have to do in these problems when we were talking about temperature and gas law problems?
You need to change in Kelvin.
Always in Kelvin. And so if I get a Celsius temperature, we just take that Celsius temperature and we do what with it?
Add 273, I think.
Perfect. That is exactly right. Okay, good stuff there, Swasti. Now, one thing that is a little bit, and I don't know that it was necessarily emphasized, and then we'll get into the problems. There are actually 4 units for pressure that I want you familiar with. So over here, let's understand that pressure comes in lots of different flavors, lots of different units. The simplest is 1 atm, 1 atmosphere. That's how much pressure we're experiencing right now because above us is 1 atmosphere of pressure. Now, 1 atmosphere is exactly the same as 14.7 PSI. That's pounds per square inch. That means that if I were to look at 1 square inch of surface area, there would be 14.7 pounds worth of push from all of the atmosphere above that particular space. Another unit that I want you familiar with is, and this is the metric unit, 101.3 kPa. kPa stands for kilopascals. All right, and so these are all just different units, and so it's not a huge deal. All right, so 1 atm is equal to 14.7 psi is equal to 101.3 kilopascals, and then there's one other unit that we want to be familiar with, because sometimes you might have to do some converting between units, and I'll explain that in a minute. All right, good morning, Carter, welcome. Hopefully you can hear me and see me. Go ahead and let me know if you can hear me and see me okay there.
I can.
Hey, good morning. Thanks for joining in. So we're just getting some prep work here before we tackle some of these problems. And then the last one that I want you familiar with is we talked about barometers and manometers and ways that we could measure pressure using columns of mercury. And so the last unit is 760 millimeters of mercury. So all of these things are equal to each other. 1 atmosphere of pressure is equal to 14.7 pounds per square inch, PSI. We've got that's equal to 101.3 kilopascals. So these are equal symbols, just written upside down or up to down. And then that's equal to 760 millimeters of mercury. And that's literally telling you that if you had a barometer, here's a container filled with mercury, and I had a tube inverted into the mercury, that column of mercury, because of atmospheric pressure, would be 760 millimeters tall. All right. Millimeters of mercury, unfortunately, also is known as torr, T-O-R-R. So I wanted to kind of go through those with all of you so that you have them. I'll give you a second to jot that stuff down. Good morning, Chris Short. How are you doing? Hopefully, Chris, you can hear me and see me, and maybe you're just having to get something to write with and write on. All right. So let's do this. Let's go ahead and I'm going to work through problem number 1 with you because I think this is an unusual problem. I think the other ones are going to look a lot like the video problems that you took some notes on yesterday. So I've got gas in an open manometer, and I'm going to go ahead and Let's see if I can zoom out just a little bit, get a little bit more space here. So I've got gas in an open manometer at a pressure of 750 millimeters of mercury. Now here's what we have in an open manometer. I've got some sort of chamber. And this is where my gas is. And there's always a U-shaped bend in it. And this end of the tube is completely open to the atmosphere. So the gas inside of this manometer, this gas in here is at a pressure of 750 millimeters of mercury. And it says if the height of the mercury is 6 millimeters higher on the open end of the tube. Well, let me do this. If the liquids, if the mercury that's sitting in here, if this liquid was sitting at the exact same level, and this pressure was 750 millimeters of mercury, Lauren, I'm going to come over here to you. If the liquid levels are at exactly the same height, and this is at 750 millimeters of mercury, so it's pushing on the liquid with a certain amount of force, what would you say about the force, the pressure on this side, if the liquids are at the same level?
It's the same.
It's the same, all right? So if this were the case, we would say that, hey, the pressure on the outside, atmospheric pressure, would be 750, but it's not saying that. It's saying that the height is 6 millimeters higher in the open end of the tube. So I'm gonna get rid of this, and I'm gonna draw a line up here. And so I've got to be thinking about this a little bit carefully, Lauren. Where would you say the higher pressure is, on the inside or on the outside?
I have no idea.
Okay, well,
On the outside.
if the pressure was high, and that's okay, if the pressure on the outside was higher, I would be pushing down on this liquid harder than this gas would be pushing. Agreed?
Yeah.
So if I'm pushing harder on this side, would this liquid go down or want to come up if I'm pushing harder on this side?
Down.
Yeah, and that's not what's happening here. So instead of the pressure being higher on this side, the pressure is actually what?
Lower.
It's lower. And it's lower by exactly this amount, all right? So if the pressure in here was 750 millimeters of mercury, we look at this and we read the problem carefully and we recognize that the pressure has to be a little bit stronger, higher in here, because it's pushing the liquid level down, it's raising the liquid level up. So do you think I would add or subtract 6 over here, Lauren?
Subtract.
Yep. And I'm not going to worry you too much about problems like this, but since it was on the sheet, I wanted to work through this one with you. This one is going to be 750 minus 6, 744 millimeters of mercury. And that would be problem number 1. All right, now here's what I'm going to do. There's 6 of you guys here today. All right, I'm going to step back a little bit and give you guys an opportunity to, and if you want to put on your cameras, that's cool because it's nice to see you, but if you don't, I totally get it. All right, these are the problems. All right, and what I'm going to suggest that we do is kind of do a little bit of time working on these together. I'm going to zoom in just a tiny bit. If you did the video notes from the other day, these should look similar. You're going to basically just make, write down the information and get to work. So with that, I'm going to stop the recording and I'm going to kind of stop talking and give you guys an opportunity to work.